in certain examination 500 students appeared, mean score is a 68 and SD is a 8. Find the student scoring less than 50 and scoring more than 60. As this is a normal distribution, as here the distribution has mean 68 and sigma, that is standard deviation, as 8. For normal distribution we need normal variable. For that we use the relation of normal variable and random variable. Z is equal to x minus x bar divided by sigma. Now we have here two example. As in first we have to find number of students score less than 50. Now as inequality is less than 50, so take variable x as a 50. For x is equal to 50 we find z. For that we put 50 in a formula. So 50 minus x bar 68 divided by 8. Now the subtraction minus 18 divided by 8 is equal to minus 2.25. That is z is equal to minus 2.25. We represent this z on a normal curve. For that we take a bell shape curve. We know as maximum height represent point on a curve as a mean of distribution, that is 68, and corresponding z on a normal axis as a 0. Now here is a variable is a 50. So as it is a less than 68, we take any point left on a curve left side of 68 as a 50, and corresponding z is here minus 2.25. Now we have to find this number of students having score less than 50. That means the area which is the left side of this line. So to find this area having z less than minus 2.25 is equal to actually 0.5 minus area from z is equal to 0 to minus 2.25. This is non-shaded area. As 0.5 minus this area is given as 0.4878. Now taking subtraction to 1 0, that is 0.122. Now this is the area which represent number of students scoring less than 50. As this total area is for 500 students, so total student getting marks less than 50 multiplied this area by 500. So 1 5 into 1 6. So 0 1 2 3 4, that is 6.1. that is 6 number of students score less than 50 than 60. As here take variable x as a 60. So for that we evaluate normal variable by putting x as 60 in a formula. So 60 minus 68 divided by 8, that is minus 8 divided by 8 is equal to minus 1. So z is equal to minus 1. Represent this z in a normal graph. As we take normal curve as we represent maximum height, the point on the curve represent the mean of distribution 68, and corresponding z on axis is a 0. Now 60 is less than 68, so we take point on left of 68 on the curve as a 60, and corresponding z to this 60 is a minus 1 on a axis by putting perpendicular on axis. Now we have to find here the number of students having scored more than 60. Now more than 60 means the area which is on right hand side of this line. As you can observe, the area having z greater than minus 1 is equal to the area from minus 1 to 0, z is equal to minus 1 to 0 plus actually 0 which is on right hand side, which is area 0.5. Now area from minus 1 to 0 is the area of 1 is given 0.3431 plus 0.5. Now addition is there, so 5 plus 3 8, 0.8431. Now total number of students scoring more than 60, as this is a total distribution of 500 students, so this area 0.8431 multiplied by 500. Now putting 0 0 5 into 1 5, 5 into 3 15 plus 1 5 21, 8 into 5 40, 40 plus that is 422 number of students are scored above 60 out of 500 students. In test of 200 electric bulbs, the bulbs has a life is normally distributed with average life 2040 and standard deviation 6.4. As this is a normal distribution in solution, we define first here the average, that is mean x bar is a 2040 hours, as standard deviation is a 60 hours. Now, as this is a normal distribution, for normal distribution we use normal variable by using relation z is equal to random variable x minus mean x bar divided by sigma. Now we have to solve here two examples. Now in first, as we asked estimate how number of bulbs having life between 1920 hours and 2160 hours. As we have given two variable, so first random variable, as we take x1 as 1920, to corresponding x1 we evaluate normal variable z1 by putting x1 1920 in the formula as a x, so 1920 minus 2040 divided by 60, as this is a minus 120 divided by 60 is a minus 2, so first normal variable is a minus 2. Now corresponding to second random variable x2 as a 2160, we evaluate normal variable z2 as putting x as a 2160 in the formula, as x bar is a 2040 divided by sigma as a 60. We define 120 by 60 as a 2, so z2 is equal to 2. Now we can define the z1 z2 in a normal graph, as we know the graph which has a bell shaped curve and a normal axis. At maximum height we define the point on the curve is a average as a 2040, as a normal variable as a 0. Now first random variable is 1920, which is a less than this, so I take this as a 1920, and corresponding left as corresponding z is a minus 2, which we take by putting perpendicular. As the second variable is 2160, which we take here as 2160. Now putting perpendicular on normal axis, we get corresponding z as a 2. Now we have asked the number of bulbs having life between these two variable, so we shaded the required area. As the shaded area from figure we define as area from z is equal to minus 2 to 2. Now this area is divided into two parts, as area from z is equal to 0 to minus 2 plus area from z is equal to 0 to 2. Now as we given area of z is equal, area of 2 is equal to 0.4772, so as this is a symmetrical, so both the areas equal, so first we put as area from 0 to minus 2 as 0.4772 plus second area is also 0.4772, adding 22474 we get 0.9544. As total bulbs is equal to, as this is distribution of 2000 bulbs, so multiplying this area by 2000 we get the required answer, as the answer will 4 into 2 8, 5 into 2 0, 19. So 1909 bulbs out of 2000 have a life between 1920 hours and 2160 hours, more than 2150 hours. So here random variable x is a 2150, so corresponding normal variable z is by putting x as a 2150 in formula, as x bar is a 2040 divided by sigma 60, as we define this as 1.83, calculating by putting now we represent this z in a normal graph. As we know the maximum height on a curve is a mean, that is 2040, as x is a 2150, which is more than average, so we take it on right hand side of it. So by putting perpendicular we get point z, which is a 1.83. now we have asked the number of balls having life more than this, that means the area which is between on right hand side of this line. As we are provided here area up to 1.83 is a 0.46, that means this area is a 0.4664. now we have area which is shaded to find. So area having z more than 1.83 is equal to 0.5 minus area from z is equal to 0 to 1.83. so 0.5 minus 0.4664, that is a 6330. now total number of bulbs, as this is distribution of 2000 bulbs, we multiplied this area by 2000, we get the answer. So by multiplying, by putting 6 into 2 12 into 6 7 into 6, as we put 4 1 2 3 4, that is 67.2 or 67. That means 67 number of bulbs have a life more than 2150 out of this 2000 electric bulb.